So today we're going to talk about management and routine. One question for management is that why do we need management at all? So you probably will say, oh sure, because we need a manager to coordinate people's action. But that's not necessarily the case that you need a manager to coordinate. We can agree on routine, then we just do that. Okay, to illustrate that example, now let's say you got yourself into a game like this, basically a coordination game. Either you two work on left or you two work on right. It does not matter which one you want to work on, as long as you fix on one pair. That is what we call routine. And in this case, there is no need for management because as long as we are being able to coordinate consistently over one pair, which is what routine is, then we'll be fine. So now let's do a different model. Okay, so now let's say we only know that we'll get theta and theta. And with probability p, theta will turn out to be 3, and with probability 1 minus p, theta will turn out to be 1. Okay, so here is a situation where management could be valuable because when theta is 3, we would like to coordinate on L. But when theta is 1, we would like to coordinate on R. That's basically intuition. Now let's show that mathematically. So let's say if we use routine, then our expected payoff is, let's say we always work on theta or on LL. So the expected payoff from playing LL is we got a probability P that we'll get utility 3, and with probability 1 minus P, we'll get utility 1. And here we have symmetric utility for each player, so it doesn't matter which player we're analyzing on. So this will turn out to be 1 minus 2p. And utility R is just 2. What does that mean? Now let's graph it out. So this is p, this is 0, this is 1. This is the utility. So first option is you always choosing on R. It gives you 2 units of utility. Or you can choose on fixing on L. When P is 0, it gives you utility, it should be 2p or plus 2p. It gives you utility 1, and when P is 1, it gives you utility 3. So excuse me for my bad drawing, but it should be crossing at 0.05. So if the uncertainty is that it favors low value, you would like to working on 2, while the uncertainty with high value, you would like to work on L. So you want to take the risky option. So now let's introduce the management. So the management says, okay, pay me a fee of k. Now let's say k equal to 0.03. I will let you know whether or not you are in high or you are in low. So if you are in high, I'm going to give you if theta turns out to be 3, I will tell you it's turns out 3, so you're kind of working on R. So now my utility becomes still 3 times P, but when it turns out to be 1 minus P, which is theta equals to 1, I tell you so that now I can do the optimal thing and coordinate on R. So I will get 2, but I'm going to pay you. So it's going to be 2 plus P minus K. Okay, and K is 0.03, so it essentially is 1.7 plus P. So now when P is 0, I get 1.07, and when P is 1, I got 2.7. So notice an interesting property here. It actually, the management curve across the, so this is, let me graph it better. This is RR routine. This is LL routine. And this is the management. When the uncertainty is low, in the sense that it is either extremely likely to be low value or extremely likely to be high value. Okay, in this actually we can work out the value. So when this value should be p equal to 0.3, and this value should be p equal to 0.7. So either when p is from 0 to 0.03, it is very likely that you get a low value. When p is from 0.07 to 1, it's very likely you'll get a high value. Okay? When you know the probability, then you prefer to work on a certain routine rather than hire the management, because it costs you money. Because otherwise you already know what's the optimal thing to do. What management brings to the table is when the certainty is high. So you actually do not know what the state of the world is likely to turn out to be. That is when the management, in this case, become extremely valuable, because it can tell you which of the state of the world is, and you can do the optimal thing. And you will notice that the management value is largest when p is 0.05, exactly because when p is 0.05, the uncertainty is the highest one. Okay? But management is not necessarily always good. Now let's say if I charge you for 0.07, so now my value is going to be 0.03 plus p. Okay, and so I will get something like 1.3 to 2.3. And in this case, you can notice that when the uncertainty is low, graph it better. When the uncertainty is low, you actually much prefer to just fix on routine of RR, and when uncertainty is high, you will be much better fixing on routine LL. And nowhere in this curve is management optimal, because management fee is too high. Its cost outweighs its benefit of eliminating the uncertainty of the world. So that is the trade-off of between management and routine. And I think hopefully that is a valuable insight.